Yeah.
Okay.
Imagine a function's derivative. Let's say f prime of x is equal to 3x squared. Now, based on what you know about derivatives and the power rule, you could reasonably figure out what you think this derivative came from. You would probably say the original function f of x was x cubed, because the derivative of x cubed is 3x squared. And this is a reasonable assumption based on what you know about derivatives and the power rule. However, this isn't entirely true, and we'll see how to do this in a minute. In this section, we're going to talk about a completely new topic called antiderivatives. And as you might expect, antiderivatives are the opposite of derivatives. If I give you a derivative, can you find the original function going the opposite direction? Or if I gave you the original function, could you take it one step further and go up one more step from that? We'll first need to use a new notation to really talk about antiderivatives. Because we're not always going to start with the derivative and try to find the original function. We might start with an original function, let's call it f of x. And from there, we can find its antiderivative, so going up a level, we can find its antiderivative, capital F of x. So this is the original function. If you find the antiderivative, you actually go up one step, and you get to its antiderivative, which is capital F of x. Previously, we were just using lowercase, but this capital letter is a way to show that it's one step above the previous one. And yes, if you have this capital F function, and you take its derivative, you're going to end up with the regular function, or just f of x. Let's revisit that problem from earlier, except this time, instead of calling this the derivative, we'll call this the original function. We'll say the original function is 3x squared. And we want to know, what is this function's antiderivative, capital F of x? This is where it gets kind of weird. If you weren't thinking about it, you'd say, if f of x equals 3x squared and capital F of x, or the antiderivative to f of x, we would say this would be x cubed, if you weren't thinking about it. However, let's think about this a little bit. Let's imagine that you try this out and you say, okay, we have f of x and that's x cubed. What's the derivative of f of x? So you'd say, well, the derivative of capital F of x, which is equal to our original function, is 3x squared. This seems to make sense. But imagine some other function. This function we're going to call h of x. And let's say h of x is equal to x cubed plus 2. So you take the derivative of capital H of x, which this is equal to the original function. It's equal to f of x, which is also 3x squared. Let's try one more. Let's say we have some third function, capital T of x. And this function is equal to x cubed plus 70. Take the derivative of that, and you're still just going to get 3x squared. So I guess what I'm trying to say is you can never be quite sure about the antiderivative. Because when you go up, there's a possibility that this happens. If there's a constant just added on the end, and then you go to take its derivative, you're always going to end up with the same thing. This function has a derivative of 3x squared. This function also has a derivative of 3x squared. And the function that we thought it would be, that also has a derivative of 3x squared. So how are you going to know which one it is? How are you going to know what's the true antiderivative? And at this point in our calculus, you're not able to know yet. So what we're going to do is, if you want to take the antiderivative, you would say something like this. You would say the antiderivative is x cubed plus any number, any constant. The C stands for constant. So it could be x cubed plus 0, Could be x cubed plus 2, could be x cubed plus 70, could be x cubed plus anything. The thing is, we're not quite sure. So if we were given the original function f of x, and we wanted to find its antiderivative, we would say it's x cubed plus 3. Let's just clean that up and summarize it here in the top right. So if our original function was f of x equals 3x squared, our antiderivative, capital F of x, would be x cubed plus c.